Welcome back, builders and makers. I'm back in the workshop today. I've been working on various projects, but this one came up in the meantime. I thought it might interest some of you. I was helping somebody out with their code and also discovered a couple little bugs with my software, so you can expect an update soon. Anyway, I've got 3 green LEDs here. Make sure you mind the polarity. There's one red LED. There are 220 ohm resistors in line with these LEDs, and I've got them hooked to, I think, pins 22, 23, 24, and 25. Pretty simple circuit. The idea here, of course, is that they're going to follow the lights on the gear here. So you can see the three green lights are off. The red in transition light is on, which means the handle must not be quite down. Let me unpause the aircraft here so we can do a test. Okay, now we have 3 green and no red. I'm going to go ahead and move the gear up, and you can see they're in transition, and then eventually the 3 lights turn off. I think that this model, the aircraft model, I believe that it is a little bit incorrect in that immediately when you start moving the gear, the lights should turn off, indicating that they are not locked. But I didn't write the aircraft model. I think that my the code in my sketch is actually representing this properly. Let me do it one more time. There's down. You can see it in transit. And then the lights that the green lights indicate in sync with the nose gear, left main gear, and the right gear. And to me, once I start moving the gear handle, those lights should turn off. I'll do this before the airplane crashes. There we go. And we're good. So that's what that looks like. This time I remembered to disable my video capture device, but there are lawns being mowed in the background, so just bear with me on the sound. I'm going to go through this sketch real quick on how it works. This is, I'm calling it XPLPro gear status, which is pretty direct. This will be available in the examples of the library as well. I just keep adding those in. I haven't updated that for a little while, so I'll try to get that done pretty soon. I've defined 4 pins for the LEDs, the 22, 23, 24, and 25 for the left gear, right gear, nose gear, and transition LEDs. I have 2 data refs that I'm going to use. One of them is for an array of floats that tell us the position of each gear on the aircraft. We'll talk more about that in a little bit. This data ref is how we get the information on the red transition light, if it should be on or off. Don't forget to define your LED pins as output pins so the processor knows they can send power to them. Initially, I'm setting those LEDs low to turn them off. No changes here. I'm going to come back to the inbound handler. Let's look at the registration. The first data ref was the gear unsafe. This is the data ref that I'm referencing. This one returns just an integer value of 1 if it's unsafe and 0 if it's safe. Here I'm requesting that data ref send us updates when it changes. This data ref is for the array of floats that tell us the position of the gears. This is the data ref associated with it. We do have to individually ask for a subscription to each element of this array that we want, because I think this array has 10 elements in it. We don't want those being sent every time. So when we request updates, I do so. And the last parameter here is the element that we want. 0 is the nose gear, 1 is the left main, 2 is the right main, and so on. If you have an aircraft with more than 3 landing gear, you would just add to that. I don't need updates any more than every 100 milliseconds. That's 10 times a second, because we're not probably putting our gear up and down that much anyway. This is the precision that I want. This could be 1 if you only want whether it's up or down. I decided to change it to 0.1 so that we get 10 levels of information between when it's all the way up and all the way down. And that's pretty much it for that. The inbound handler here, there's 2 data refs we're looking at. So if the handle is the gear unsafe, we're going to examine the information that was sent and turn the transition light on or turn it off as appropriate. In this case, since this is an array, it's still the same data ref handle, but we also get sent information about which element that is sending to us. So we have to, I'm using a switch and case methodology here to determine it. So we look at this element. If it's 0, 1, or 2, then we examine the information that was sent with it and then write to the appropriate LED. And that's it for this sketch. I hope this is helpful to you. Please like and subscribe to my channel. It does encourage me to make more videos, and it lets me know that somebody is paying attention to what I'm doing. I'll see you in the next video. Have a great day.